Lesson 1-9, a preview of graphs and functions. Objective of this lesson, to interpret graphs in real-world settings and to sketch graphs for given functions. Let's take a look at this example in economics. The dollar value of a car begins to decrease immediately after it's sold. Okay, meaning as you take it out of the sales lot, the value of the car immediately decreases. This is called depreciation. Mathematically, depreciation can be defined by the following open sentence. Okay, so depreciation is equal to the original cost of the car minus the value of the car when sold. Again, this is an open sentence because you have a few variables here that we don't know: original cost of the car and the value of the car when sold. So the table below shows how a typical $15,000 car depreciates over a period of 5 years. And from the table, you can see as the age of the car increases, the value decreases. Why do you think this happens? Because when you think about a car, the car has a lot of moving parts. And as it is being used, as it is being driven, there's a lot of wear and tear that happens in the car. Okay? And when this happens, the value of the car starts to go down because of the various wear and tear inside the engine or different parts of the car. Okay, and that's why the car begins to lose value as it ages. Okay, so at year 1, you have the approximate value of the car at 15,000. Year 0, and year 1, 11,000, all the way down to year 5. Now the value of the car is at $4,000. Okay, this information can also be presented in a graph. I think I wrote this down twice. Yes, I did. Okay, the graph below shows the relationship between the current value of the car and the age of the car, and this is the graph that we have there. Okay, current value of the car and the age of the car. Car depreciation over a 5-year period, and if you notice on the vertical axis, we have the approximate value of the car in thousands of dollars. On the horizontal axis, you have the age of the car in years. Okay, and these points are the points that we have on our table right there. Okay, so the value of the car is said to be a function of the age of the car. A function is a relationship between input and output. In a function, the output depends on the input. There is exactly one output for each input. So basically saying, if I am going to rephrase this sentence, the first sentence, I can also say that the value of the car is dependent on the age of the car. Okay, meaning to say the value of the car and the age of the car are related to one another. As the age of the car increases, the value of the car begins to decrease. And from that, you know that as a relationship, as the output, okay, as our output, which is the value of the car, is dependent on the input. Okay, and our output, okay, is always on the y-axis. Okay, our input is always graphed on the x-axis, and there's only exactly one output for each input. Okay, taking that one step further, there are two number lines on the graph: the line that represents the current value of the car's vertical axis, and the line that represents the age of the car is the horizontal axis, or the y and the x-axis in our coordinate plane. Okay. Notice that there are 6 points shown on the graph. Each point represents the dollar value of the car in thousands at the end of the year. For example, after year 1, the value is 11,000. You can express this relationship as 1 and 11. Okay, so after year 1, right here, okay, after year 1, the value is 11,000, and that's what it's saying. So this is now 1 and 11. Okay, that ordered pair is 1 and 11. Where 1 represents the age of the car, okay, and 11 represents the value of the car. Okay, So at year 1, the value of the car is around $11,000. Okay, and let's take a look at some other questions that have been expressed in this one. What do points A and B represent? Okay, A and B right here. The x-coordinate of A is 2 and the y-coordinate is 8. So A is actually ordered pair 2, 8. What does that represent? Okay, it simply represents at the end of year 2, the value of the car is about $8,000. And if you look at point B, it's the ordered pair is 3 and 6. Okay, so in point B, it's 3 and 6. And just like point A, the meaning of 3, 6 is that at the end of year 3, the value of the car is $6,000. Okay, and we call 1, 11, 2, 8, and 3, 6 ordered pairs. Okay, the order in which a pair of numbers is written is important. It is always in the form of X and Y. So when you talk about what, and the reason why they're called ordered pairs is because it's always in the form of XY, XY, XY. They're always in that order. The order in which the pair of numbers is written is important. Ordered pairs are used to locate points of the graph. The first number in the ordered pair corresponds to the horizontal axis, and the second number of the ordered pair corresponds to the vertical axis. And if you notice, as a review, we call the x part of an ordered pair as our x-coordinate. Okay, and the y part as is considered to be the y-coordinate. Okay, review that in 7th grade and in 6th grade as well. The first number in the ordered pair corresponds to the horizontal axis. The second number corresponds to the vertical axis. The ordered pair 0, 0 corresponds to the origin. So when you have an ordered pair 0, 0, it is also called the origin. Many real-world situations can be modeled using functions. Let's take a look at how that is the case. So, Shim owns a farm market. Amount of customer pays, the amount a customer pays for sweet corn depends on the number of ears that are purchased. Okay, so again, the word depends. You can also change this into a function of, is a function of. Okay, so that one you can do too. Okay, that didn't go well. Okay, so we can also change that in the word depends can be changed into is a function of. Okay, so Shim owns a farm market. The amount the customer pays for sweet corn depends on the number of ears that are purchased. By that sentence alone, we know what the output is. We know what the input is. The output always depends on the input. Okay, so in this case, our output would be the amount a customer pays for sweet corn will be our output, and the number of ears that are purchased will be our input. Shim sells a dozen ears of corn for $3. Make a table showing the price of various purchases of sweet corn. Okay, so the number of we know that if we have half a dozen of ears of corn, okay, and let's say there are 6 ears of corn, the price would be $1.50. Okay, if you have 1 dozen, 12 ears of corn, okay, that would be $3. 1½ dozen, and let's say you have 18 ears of corn, that would be $4.50. Okay, And if you have 2 dozen ears of corn, okay, or sorry, 2 dozen and 24 ears of corn, you end up with $6. Okay? Again, this is dependent on the sentence. Shim sells a dozen ears of corn for $3. So if Shim sells 1/2 dozen, okay, six, and that's 6 ears of corn. Okay, that'll be half of the $3, and that'll be 150. 1 dozen, okay, that'll be 12 pieces ears of corn, $3. 1 1/2 dozen, that'll be 6 plus 12 or 18 ears of corn for 50, and 2 dozen will give you 24 ears of corn for $6. Okay, so write 4 ordered pairs that represent the number of ears of corn and the price of the corn. So ears of corn, price of the corn. Okay, so in this case, the price will be dependent on the ears of corn. So the price will be your x coordinate, ears of corn will be your y coordinate. So it can be 6 ears of corn, okay, for $1.50. Damn it. Example 1. Shim owns a farm market. The amount the customer pays for sweet corn depends on the number of ears that are purchased. Okay, so in this case, the price is dependent on the number of ears that are purchased. So if you look at this one carefully, the output is the price, and the input will be the number of ears of corn, okay, that are purchased. And it says there also that Shim sells a dozen ears of corn for $3. Knowing that last sentence, we can make a table showing the price of various purchases of sweet corn. Let's say you have half a dozen, okay, and that will mean that you have 6 ears of corn, okay, which will have $1.50 because a dozen costs $3. Okay, 1 dozen, okay, 12 ears of corn will cost $3, like what the last sentence says. Okay, 1 1/2, okay, 18 ears of corn will garner a price of $4.50, and 2 dozen will mean 24 ears of corn at $6. Letter B, write 4 ordered pairs that represent the number of ears of corn and the price of the corn. Okay, 4 ordered pairs can be determined. These are 6 and 150, 12 and 3, 18 and 4.5, 26, 24 and 6. Okay, the 2 numbers mentioned there. It says in letter C, describes a set of axes that could be used to graph the number of ears of corn and the price of the corn. And we let the horizontal axis, or the y-axis, sorry, the x-axis, represent the number of ears of corn, because this is your input. Sorry, yes, that's your input. Okay, and the vertical axis, or your y-axis, will represent the price of corn, or your output. So if we label this will be your x-axis right here, and this will be the price, will be your y-axis, meaning the price will be dependent on the x-axis, or the ears of corn. Okay, so it's asked draw a graph that shows the relationship between the number of ears of corn and the price of the corn. Okay, the graph will look something like this. Okay, so the price again is on the vertical axis, and then the ears of corn will be on the horizontal axis. And it's saying in this graph that asks you for every 6 ears of corn, the price is $1.50. For every dozen ears of corn, the price would be $3. For every 18 ears of corn, it'll be $4.50, and for every 24 or 2 dozen, okay, ears of corn, you'll have $6. Okay, and as you read the graph from left to right, describe the trend you see and explain. Well, obviously the graph goes upward because the price increases as the number of ears increases. The price is a function of the number of ears purchased. Again, we can say that the price is dependent. Okay, you can also replace that. Dependent, okay, on the number of ears purchased. Okay, so in example 1, the customer pays the price the customer pays depends on the number of ears purchased. Therefore, the number of ears purchased is called the independent variable or quantity, and the price is called the dependent variable or quantity. Usually, the independent variable is graphed on the horizontal axis, and the dependent variable is graphed on the vertical axis. Okay, so when you talk about independent variables, okay, this is always graphed on your y-axis, and the dependent variable is usually graphed on the vertical axis or the x-axis. Okay, a few important things to take note of. Okay, for a certain time, let's take a look at example number 2. Lucinda jogs up a hill at a steady speed. Then she runs down a hill and picks up her speed. What happens to her speed when Lucinda jogs at a steady pace? When Lucinda runs down the hill, okay, what happens is that the speed remains the same when her jogging pace is steady. The speed increases when she runs downhill. Okay, that's exactly what happens when you talk about Lucinda's situation. The independent quantity is your time, and the dependent quantity is speed. Another tip that you can write down is time is always independent. When you see time in any situation and you need to graph that situation as a function, okay, time will always be the independent quantity, or time will always be your x-axis. Okay, and let's look at the 3 graphs to find out which match Lucinda's situation. And look at graph 3 first. Okay, her speed increases, okay, and then she runs at a constant speed because now the speed does not increase but as the time increases. In graph number 2, her speed increases, but at a certain time her speed begins to go down. In graph 1, her speed is constant, and then at a certain time it begins to increase. So if you notice, in terms of Lucinda's situation, remains the same when her jogging pace is steady, then the speed increases when she runs down the hill. We have graph 1 that best describes Lucinda's situation. Okay? Let's take a look at the next concept in this lesson. A relation is a set of ordered pairs. The set of first numbers of the ordered pairs is the domain of the relation. The domain contains the value of the independent variable. The set of second numbers of the ordered pairs is the range of the relation. The range contains the values of the independent variable. Okay, another summary that we can do for this one, if let's say your ordered pair is x and y, okay, x is also your domain and y is your range. Okay, x is also your independent variable and y is your dependent variable. Okay, so that's another way of looking at an ordered pair. X is your domain and your independent variable, y is your range and your dependent variable. Let's take it one step further. X is your input and y is your output. Okay, the range contains values of the dependent variable. I've just read the last sentence here. Okay. Ryan is not feeling well and has missed a day at school. The graph shows Ryan's temperature as a function of the time of day. And if you notice here, time is still on the horizontal axis, which represents your independent variable. And look at the temperature of Ryan. It goes up in the morning, then comes down as it becomes noon, and goes up again in the afternoon, mid-afternoon, and goes down late afternoon. Write a story about Ryan's illness. When Ryan got up in the morning, he had a high fever. As the morning went on, his temperature went down. By noon, it was almost normal at 98.6, normal temperature. But his temperature went up again after lunch. Then his mom gave him some medicine. By evening, fever was gone, and the temperature was back to normal. Okay? Identify a reasonable domain and range for this problem. And like what I told you, domain is your independent variable, range is your dependent variable, which follows. The domain includes the 24 hours of the day or the time. A reasonable range would include all of the temperatures between the highest and lowest temperature person can have and still be alive. Obviously, you would not write down 200 degrees right there, because that's not even logical to put on the vertical axis. Okay? And that is example number 3. And thank goodness we have ended this lesson. So on Google Forms, type a summary of what you've learned by responding to the objective of the lesson, and type a question you might want to ask in class. Thank you.